So in the previous examples, in order for us to determine if the inverse was a function, we had to graph it, which can be a pain. It can be time consuming, and who wants to do that for every single problem to see if the inverse is a function? Well, there is another way to do that without having to do any graphing. Now, I want to be very clear. Remember when we looked to see if, let's get this one up here, when we looked to see if this red graph was a function, we used the vertical line test. And we could see that using the vertical line test, it's not a function because the vertical line passes through 2 points. We could tell by looking at this purple graph that it was a function because of the vertical line test, and the vertical line would only pass through 1 point. Now, we use the vertical line test when we're looking at a specific graph to see if that graph is a function. Now, to save us some time to see if the inverse is a function, we're going to use the horizontal line test. Okay, this is really important. Now, a horizontal line test is used to see if the graph that we're not looking at is a function. Let's look at some examples. Let's look at this first one here. It says, tell whether the inverses of the graph functions are functions, explain your reasoning. So we can tell by looking at just this specific function by using the vertical line test that this graph is a function, because no matter where I draw a vertical line, it's going to pass through just 1 point. Now, we can look to see if the inverse of this is a function, again, without having to graph it, by just drawing a horizontal line. Okay, that's not a horizontal line. And you can see that when I draw a horizontal line, it passes through this graph more than once. In fact, it passes through multiple times. So we can tell that for part A here, that since it fails the horizontal line test, that this first graph, its inverse, is not a function. And the domain here, just to review, the domain of each function means what we're looking at right now. The domain would be all real numbers, because the graph goes infinitely in both directions along the x-axis. The range for this along the y-axis goes from a positive 3 to a negative 3. So the way that we'll write this is it's going to be the set of all y's such that negative 3 is less than or equal to y, which is less than or equal to positive 3. Now it says state the domain and range of the inverse. Well, we don't have a graph to figure that out, but remember, when we find the inverse, what do? We switch the x and the y. Remember what that implied was that we also, when we're switching the x and the y, what we're doing is we're also switching the domain and range. So what that means is the domain for the inverse here would be the set. Now this is, I'm going to get that from the range, but remember the domain is dealing with x's, not y's. So I'm going to say the domain is the set of all x's such that the set of x's would be between negative 3 and positive 3. If I were to graph the inverse, the range then would be all real numbers. So all I did is I switched those two. So looking at graph number 2 here, this one, its graph is a function. To find if the inverse is a function, we draw a horizontal line, and sure enough, it goes through 2 points. So the inverse of this would not be a function. And if we wanted to find the domain and range, we do the same thing that we did here. The domain of the original, which was a function, is going to be all real numbers. The range for this one would be the set of y's such that y is less than or equal to 2. Because remember, it starts here where y on the y-axis where y is 2, and it goes down, so it's everything below that point. And if I wanted to find the domain and range for the inverse, which we don't have graphed, all I have to do is look up here at what I put for my domain and range for the original function, and I would say the domain for the inverse would be the set of all x's such that x would be less than or equal to 2, and my range would be all real numbers. So you can see this is much easier than having to graph each of them out. I want you guys to take a minute now and figure out if these last two examples, if the inverse of those are functions, and then also take a minute to find the domain and range for each of those. So why don't you go ahead and pause the video. When you get finished, start playing it again. Okay, for this example number 3 here, you should see that the inverse here would be a function. So no matter where we draw a horizontal line, it's only going to pass through the point, or graph at one point. So the inverse of that is a function. To find the domain and range, this one, the domain of the original, would be all real numbers. This doesn't go straight up. Remember, it is gradually increasing to the right, and it's gradually increasing as we go to the left here. So the domain is all real numbers. The range, you can see from the graph, this is real obvious. It goes infinitely up and infinitely down. So the domain is, or the range is also all real numbers. Which, instead of taking the time of rewriting all this, it's going to be the same for the inverse. Now for this one, the inverse is not a function because it fails the horizontal line test. The domain for the original function would be all real numbers. The range for this, that starts here where y is 2. So it's going to be the set of all y's such that y is less than or equal to 2. So to find the domain and range for the inverse, we would say the domain is going to be the set of all x's such that x is less than or equal to 2. And the range is going to be all real numbers. So there you have it. So hopefully you have a better concept now of how to find the, or determine if the inverse of a graph is a function, and how to find the domain and range. So good luck on your homework assignment.